In this lesson, we're talking about geometric probability. What we're going to do is use the areas to solve problems involving geometric probability in terms of polygon shapes, circle shapes, things like that. And we'll estimate or calculate simple geometric probabilities. What is probability? It's a measure of the likelihood that an event will occur. It always is a number between 0 and 1 inclusive, meaning it could be 0 or it could be 1. And we can express it as a fraction, a decimal, or a percent. The probability of an event, A, is written as P of A. So that could be P of rolling an even die. That could be P of rolling a 6 on a die. It could be P of throwing a dart into a particular region. Probability, as I said, always lies between 0 and 1. If it is 0, that means the thing is impossible. If it is 1, it means it is absolutely certain. Probability of 0.5 or 50% is equally likely to occur as not occur. If less than 50% is unlikely and more than 50% is more likely than not. Geometric probability is any probability that involves a geometric measure. So probability and length. Basically what we're saying is in terms of length, if AB is a segment that on AB lies another segment CD, if a point is picked at random on that line, what we're looking for, probability is always the favorable outcomes over the possible outcomes. So in this case, the favorable outcomes would be a point inside of CD, so I'll take the length of CD, and the possible outcomes is any point on AB, so I'll take the length of AB, and my probability that K is on line segment CD is the ratio of the lengths of the desired line segment and the overall line segment. So in this case, let's look at a few. Find the probability that the point chosen at random on PQ is actually on RS. So what I need to do is think of my probability. I need to find the length of RS and the length of PQ. Remember that my probability is the length of RS in relation to the length of PQ. Since RS has a length of 6 and PQ has a length of 10, that is 6 out of 10. You could reduce that to 3/5. You could write it as a decimal of 0.6 or as a percent of 60%. Let's look at an example of applying this. A monorail runs every 12 minutes. The ride from the station near your home to the station near your work takes 9 minutes. So one morning you arrive at the station at 8:46 and you want to get to the station near your work by 8:58 because you need to be to work on time. So what's the probability you'll get there by 8:58? Well, let's break this down. First, let's think about what time is the very latest the train can leave your station if you're going to get there by 8:58? Well, the very latest it could leave would be 9 minutes earlier. That would be 8:49. Well, if you got there at 8:46, how long would that give you to wait for the train? Well, actually, it only gives you 3 minutes to wait. Now, what is the longest you could possibly have to wait? Well, if you got there just as the train had pulled out, then you would have to wait a full 12 minutes. So what's the probability? That's the least you can wait over the longest you could wait, in this case 3/12, which is a 25% chance of making it to work on time. So it looks like this person better get there a little earlier than 8:46. So here's some for you to try. RT. We notice the probability of RT it being on RT, if we know that it's going to land on PQ, RT is 1, PQ is 10, so 1 out of 10 or 0.1, 10%. What about TS? Well, my length of TS is 5, so 5 out of 10 is 1/2, 0.5 or 50%. PT, well, I can see that PT is 4, so 4 out of 10 is 2/5, which is 0.4 or 40%. And RQ looks to be 7, so 7 out of 10, which is 0.7 or a 70% chance. What if, in example 2, suppose you arrive at the station near your home at 8:43? What's the probability that you'll get there by 8:58? Well, remember that you would have to leave by 8:49 in order to get there by 8:58. And so that would give you 6 minutes of a wait time. Remember, the longest possible wait time is 12 minutes, so 6 out of 12 is 1/2 or a 50% chance. Probability and area. Probability that a point randomly chosen inside of J will also be inside M will be the area of M compared to the area of J. So in terms of this one, the diameter of the target shown on the right is 80 centimeters. The diameter of the red circle is 16 centimeters. If an arrow is shot and hits the target, if the arrow is equally likely to have landed on any point on the target, what's the probability that it lands in the red circle? Okay, what we need to do is we need to find the area of the red circle and the area of the target, because we're talking about the probability of it hitting in a small region inside of a larger region. So, probability will be the area of the red circle divided by the area of the target. Now, I need to think about the area of the red circle. In the area of the red circle, the radius, since the diameter is 16, the radius is 8. And for the target altogether, the radius will be 40. So we have pi times 8 squared over pi times 40 squared, which comes out to be 1/25, which is about a 4% chance of that happening. So here's you some guided practice to try. Determine the probability for each outcome of the artery shown. The center ring has a radius of 1, so from here to the outside is 1. It says each successive seam has 1 greater, so this is 1, this is 1, and this is 1. So notice from the center, the 25 is a radius of 1. From the center out to the end of the 20-point region is a radius of 2. Out to the end of the 15-point region is a radius of 3, and the whole thing is a radius of 4. So let's see how we'll do this. What about the 25-point one? Well, the area of the 25 point is simply 1 squared times pi, or pi. The area of the entire circle is the radius of 4, so that's 16 pi. So we get 1 over 16, which comes out to be about 6.25%. Okay, obviously I should have written that down a little lower. What about the 20-point one? Okay, well, let's look at that. The area of just this in here is going to be the area of the entire circle minus this one. So from my 20 points, the area of the entire circle has a radius of 2, so 2 squared is 4 pi. But I've got to subtract out this center part, which is 1 pi, and then that will be over the entire circle of 16 pi, so that is 3 pi over 16 pi, so 3 over 16 comes out to be about 8.75. For the 15 point, we're going to do basically the same thing, but what I need is this whole part, which is a radius of 3 out to the 15-point circle. 1, 2, 3. A radius of 3, so that will be 9 pi. But I need to subtract out everything in here, so that's 2 pi, or radius of 2, so minus 4 pi over the entire thing, which gives me 5 pi over 16 pi, or 5 over 6, 31.25. And then for my 10 point, let's think, we've got the whole thing, 16 pi, minus everything inside of that, which has a radius of 3, so 9 pi divided by 16 pi, which gives me 7 pi over 16. 7 over 16 is 43.75%.